আমাদের অনারেবল স্পিকার যখন এসে গেছেন এবং টাইমও হয়ে গেছে,
আজকে আমাদের ইন্টার্নশিপের চতুর্থ দিন। আমরা গত বছর থেকেই ইন্ডিয়ান মেট্রোলজিক্যাল সোসাইটির সঙ্গে কোলাবোরেশনে আমাদের ইন্টার্নশিপ করছি। তা এবারের ইন্টার্নশিপটা গত বছরের থেকে একটু আলাদা, তার কারণ আমরা প্রভু জগৎবন্ধু কলেজ এবং আমতা কলেজ যৌথভাবে হাত মিলিয়েছি এবারের ইন্টার্নশিপ করবার জন্য। এবং গত বছর আমাদের আজকের যিনি স্পিকার, আমাদের IMS এর চেয়ারম্যান, প্রখ্যাত আবহবিজ্ঞানী, আর তিনি ভারতবর্ষের আবহবিজ্ঞান দপ্তর, আমাদের ইন্ডিয়ান মেট্রোলজিক্যাল যে ডিপার্টমেন্ট, সেই ডিপার্টমেন্টের আলিপুর আবহাওয়া অফিসের অধিকর্তা। এছাড়াও তিনি অ্যাকচুয়ালি বহু বছর পুনে বিভাগে কর্মরত ছিলেন এবং বহু বছর তিনি গবেষণা এবং শিক্ষকতা একই সঙ্গে চালিয়ে গেছেন এবং এই বিষয়ে তার যথেষ্ট খ্যাতি রয়েছে। আজকে যে ওনাকে আমরা আমাদের মধ্যে পেয়েছি, এটা আমাদের কাছে খুবই সৌভাগ্য, কারণ ছাত্রছাত্রীরা জানবে যে গতবার আমরা যে বজ্রপাতে মৃত্যু রোধ করবার জন্য ইন্টার্নশিপ করিয়েছিলাম ছাত্রছাত্রীদের, এবং তারা ভীষণভাবে জিনিসটা জেনে সমৃদ্ধ হয়েছিল। এবং আমাদের যেহেতু আমাদের একটু রুরাল সাইডের কলেজ, আর এলাকার মানুষ কলেজের সঙ্গে খুব সম্পৃক্ত থাকে, তাই যখন আমাদের ছেলেমেয়েরা নানান ধরনের সামাজিক ক্যাম্পেইন তৈরি করেছিল, তারা ভীষণভাবে সাধুবাদ জানিয়েছিল। তা এবারেও আমরা একটু অন্যভাবে এইটাকে সাজিয়েছি। আজকে এই আবহবিজ্ঞানী শ্রী দত্ত তোমাদের সঙ্গে আলোচনা করবেন, সেটা হচ্ছে যে আবহবিজ্ঞানের যে একেবারে বেসিক আদি জিনিসগুলো, সেইগুলোই খুব সহজ ভাষায় তোমাদের সামনে তিনি তুলে ধরবেন। ঠিক আছে, আমরা এবারে আর সময় নষ্ট করব না, তোমরা মন দিয়ে ওনার কথা শুনবে এবং উনি যদি কিছু প্রশ্ন করেন বা তোমাদের কোনো প্রশ্ন থাকে ওনার সঙ্গে সেটা সহযোগিতা করবে। ঠিক আছে স্যার, এবারে তাহলে আপনি শুরু করুন।
Thank you very much for your introduction about me. First of all, I wish to express my sincere thanks for giving me an opportunity to speak a few words and to discuss few things with your students, with the students of your esteemed college. So as such, I don't know that how much you will be benefited, but I feel myself very much fortunate that I got this opportunity to discuss with these birds. So now, actually, this proposal I gave it to Professor Saroda Mandal. So actually, what happened? I understand that all you are studying climate science, climatology, so many things. But one thing, actually, it is being said in our fraternity that without knowing the weather, you cannot talk about the climate. I mean, without knowing the atmosphere, without knowing that a few basics of the atmosphere, you cannot go ahead actually. So for that, actually, I just suggested her that you can have a talk on basics of atmospheric science. Okay, because sometimes back I discussed this thing with lot of students at your Central Glass Research Institute, Jagatbandhu. So this will be, I hope that this will be really helpful for you. You can, students and anyone can ask me any question. Okay, so with this small, and again thanking to all of you. As such, I am extremely sorry, Madam Saroda invited me to her college, but due to official difficulties, personal difficulties, and considering the distance and Calcutta road transport condition, road traffic condition, actually, I could not go. Okay, so but definitely I will try to make a visit to your college, madam. So with this, actually, now I am sharing my screen.
থ্যাংক ইউ স্যার। আপনি যে বললেন যে আমাদের কলেজে আপনি আসবেন, খুবই ভালো। আমরা অধীর আগ্রহে তার জন্য অপেক্ষা করব।
নিশ্চয়ই আসবো,
ঠিক আছে স্যার, এবারে আপনি আপনার বক্তব্য শুরু করুন।
I hope the screen is seen by everyone.
Yes, sir.
Yes. Yes, sir.
It is visible, sir.
Full screen.
Yes, sir.
Okay. So this is the topic of my lecture. This we can leave. So first of all, we should know what is atmosphere. Atmosphere is nothing but a mixture of gases surrounding the Earth's surface, which is given in the adjoining table. These are the different gases which constitute the atmosphere. So major gases are your nitrogen, which is there about 78%. You can see maximum constituent. Then after that it is oxygen, 20.95, about 21%. Then after that argon, then water vapor, very less but play very important role, 0 to 5%. Similarly carbon dioxide, very less, 380 ppm, but plays very important role with this much itself. Then neon, helium, all these things are there. Methane is also there. It is also, as per its presence, it is very less, but amount is less, but plays very important role. And this ozone and nitrous oxide, these are also less, but they play very important role. So these are the different, and these are the different layers of the atmosphere. You know, in the total atmosphere, they are having many layers. Lowermost is your troposphere, then stratosphere, then mesosphere, like that. Actually, so many layers are there. Now we are living in the troposphere. We are mainly interested for the troposphere. So there are certain characteristics of troposphere are there, that it is the lowest layer of the Earth's atmosphere. We can understand most of the mass, about 75 to 80% of the atmosphere is in the troposphere. That's why troposphere is so important. And most types of clouds are found in the troposphere, and almost all weather occurs in troposphere. And troposphere is by far the wettest layer of the atmosphere. And air is warmest at the bottom of the troposphere near the ground level, and air gets colder as one rises through the troposphere, and air pressure and air density also decreases with height upward in the troposphere up to tropopause. And tropopause is the boundary between troposphere and stratosphere. Tropopause also having a very typical character, interesting characteristic, which we will see. Now, what is the vertical thermal structure? In the troposphere, temperature decreases with height. You can see temperature has decreases with height. Decreases with height as the source of thermal effect in the troposphere is surface of the. Because why? Because what happened? Earth's surface directly receives the solar radiation. We call it solar insolation, solar heating. Okay, and immediately in response, Earth's surface gets heated. Earth's surface becomes another one heat source. So therefore, any habitant in the troposphere, if it moves away from the Earth's surface, That means it is moving away from that heat source, that is Earth's surface. So naturally temperature will decrease. There is another one reason for temperature decrease is there, because as we go, because we have seen 75 to 80% masses is in the troposphere. So therefore, as we go up, definitely atmospheric mass will become lesser and lesser and lesser. What does it means? It means density is becoming very smaller and smaller. That means volume is becoming more and more. And as the density decreases, temperature also cools down. Because we know volume increase means what? What physical process can lead to increase in volume? This is nothing but your expansion. Nothing but your expansion. And we all know very well that if expansion takes place, then what happened? Some works needs to be done by the gases, okay, to get rid of the intermolecular attractions of the gas molecules. And for that, it requires some energy, and that energy it takes from the thermal energy of the gas. As a result of which, thermal energy of the gas reduce. Thermal energy means you can understand that is heat energy reduced, as a result of which temperature decreases. And in the stratosphere, there is another one thing. Stratosphere is also very important. In the stratosphere, as the middle of the stratosphere, there is ozone is there, and ozone plays a very important role. Whatever solar radiation is coming, in the solar radiation, actually there is one part is there, that is called ultraviolet part. That ultraviolet part, it is desired that it should not reach at the Earth's surface, because it causes harm on the living body. So, and that ozone, what it does, ozone absorbs this ultraviolet ray, and protecting it. So in the status, and as a result of which you can understand, again ozone becomes a source of heat. So in the stratosphere, due to absorption of ultraviolet radiation by ozone, temperature increases with height, which you can see in the picture also. You can see. And in the mesosphere, again, it behaves just like troposphere, only temperature decreases with height. And in the thermosphere, all this ionic, all this thing, that means all molecular reaction is there, exothermic chemical reactions are taking places actually. So due to that, their heat is released and their temperature increases. In the thermosphere, temperature increases with height, and all the weather phenomena takes place in the troposphere only, as I already told. Now, in the atmosphere, we see many weather. We feel many weather also. Today I am feeling very hot as compared to yesterday, or today I am feeling more moist as compared to yesterday. Like this, so now all these things are happening due to many processes. Physical processes are taking place in the atmosphere. Number one is heating and cooling. In the atmosphere, somewhere heating is taking place, somewhere cooling. Just for example, equatorial region. In the equatorial region, maximum solar radiation is received. So therefore, heating is there, and due to heating, temperature is also there. But at the higher latitude, polar region, there cooling is there. Cooling, why cooling? Two reasons. One is your solar radiation received less, and there is a lot of glaciations are also there. So heating cooling process is there. Another one process is there. You don't worry about the name. That there is a physical process is that it is called adiabatic. This process is nothing. This process is that suppose you consider one sample of air, okay, isolated sample of air. Now suppose right now its pressure, temperature, density is something. Now you change its pressure, temperature, and all these things. But during this change, you have to ensure that that no heat from the outside should be added or if any heat is generated during this changing process, then that heat should remain there. This type of process is known as adiabatic process. So in the atmosphere, actually, two types of adiabatic processes are taking place. If the air is very, very dry, then it is a dry adiabatic process. And if the air is very, very, if the air contains good amount of water vapor, then it is a moist adiabatic process. Then in the atmosphere, saturation is also taking place. Saturation is very simple thing. For saturation, I am giving you a very small example. It is a joke you can take, as a joke you can take. You know, when I was very small, I remember in my house, in the major Purnima Tithi, Satyanarayan Puja used to be conducted. That time my Thakuma was living. And our Thakur Mosai name was Mr. Samaprasad Bhattacharya. And it was our house convention. After the Satyanarayan Puja is over, that Panditji, that is Thakur Mosai, should be provided good amount of luchi, kumro choka, cholar dal, and later on mishti. And then I remember my mother used to prepare luchi after luchi, and my Thakuma was sitting in front of that Thakur Mosai, and until that Thakur Mosai, and every time she is asking, "Are debo? Are debo? Are debo?" And he used to say, "Yes, yes, yes." And order goes to my mother. My mother again prepared puri like this. Now suppose, so now when this will over, when Thakur Mosai will say, "Bas, amar pet bhore gache, ar khete parbo na," that means Thakur Mosai is now tripto. And then my Thakuma.
Excuse me, sir.
Yes.
স্যার সরি টু ডিস্টার্ব ইউ, স্লাইড কি চেঞ্জ হচ্ছে? আমরা না টাইটেল স্লাইডটাই দেখছি।
কেন বলুন তো, এরকম তো হওয়া উচিত নয়। আমি তো স্লাইড চেঞ্জ করছি।
হ্যাঁ স্যার, এটা মনে হলো। হ্যাঁ, এবার চেঞ্জ হলো স্যার, এবার চেঞ্জ স্লাইড দেখতে পেলাম।
এবার দেখুন তো।
হ্যাঁ স্যার, হচ্ছে হচ্ছে।
না, কিন্তু কথা হচ্ছে, তার মানে যখন আমি ফুল স্ক্রিনেতে দিচ্ছি তখন হচ্ছে না। দাঁড়ান 1 মিনিট দাঁড়ান, দেখছি কি করা যেতে পারে। 1 মিনিট দাঁড়ান, আমি প্রথমে প্রেজেন্টেশন বন্ধ করে দিলাম, ঠিক আছে, তারপরে স্লাইড শো করে দিলাম। একটুখানি আমাকে কনফার্ম করুন তো, স্লাইড চেঞ্জ হচ্ছে?
না স্যার, হচ্ছে না।
টাইটেল স্লাইডটাই দেখাচ্ছে।
টাইটেল স্লাইডটা তো সিলেক্ট হয়ে আছে, যার জন্য যেটা সিলেক্ট হয়ে আছে ওটা দেখাচ্ছে।
না, তার মানে ব্যাপারটা হচ্ছে যে আমি যখনই এটাকে করছি, ফুল স্লাইড দেখাচ্ছি, তখন ওটা দেখাচ্ছে না কেন? সেটাই
স্লাইড শোতে যখন যাচ্ছেন বোধহয় তখন আর স্লাইডটা চেঞ্জ হচ্ছে না।
ওই লেফট পেনে সিলেক্ট করে আপনাকে করতে হবে।
না, সেরকম করে তো আমার প্রত্যেকবার শেয়ার করতে হবে, তাহলে তো না, সেটা তো ঠিক নয়। আচ্ছা দাঁড়ান, একটা কাজ করা।
না না, প্রত্যেকবার শেয়ার করতে হবে না, ওই লেফট পেনে ক্লিক করলেই হবে।
হ্যাঁ, কিসে?
ওই যে লেফট পেনে পরপর স্লাইডটা দেখাচ্ছে না,
হ্যাঁ হ্যাঁ,
ওখানে সিলেক্ট করে করলেই হবে।
স্লাইডস গুলো যেখানে দেখাচ্ছে
হ্যাঁ
লেফট সাইডে, সেইখানে সিলেক্ট করে গেলেই।
হ্যাঁ, তো ওখানেই তো। এই যে এখন ধরুন দেখাচ্ছে, তাই তো, ফুল স্ক্রিন, তাই তো?
স্লাইডটা টাইটেল স্লাইড।
অ্যাকচুয়ালি স্যার আমরা না ফুল স্ক্রিন হিসেবে দেখতে পাচ্ছি না, নর্মাল পাওয়ার পয়েন্ট ভিউটাই দেখছি। মানে আপনি যে ফুল স্ক্রিন করছেন ওই ফুল স্ক্রিনটা হচ্ছে না আর কি।
তাহলে দরকার নেই, তাহলে এরকমই চলুক। এখন দেখুন তো, ঠিক আছে?
হ্যাঁ, চেঞ্জ হয়েছে, সেকেন্ড স্লাইড দেখতে পাচ্ছি আমরা।
আচ্ছা, কোনো অসুবিধা হচ্ছে না না দেখতে?
না, কোনো অসুবিধা হচ্ছে না,
তাহলে এরকমই
সেটা
চলুক,
কি ঠিক?
ঠিক
হ্যাঁ
আছে?
স্যার ক্লিয়ার আছে, আপনি ম্যানুয়ালি ওই স্লাইড সিলেক্ট করে করে করলেই মনে হয়ে যাবে, অসুবিধা হবে।
হ্যাঁ
ঠিক আছে। তো
ঠিক।
হ্যাঁ, এগুলো তো বাদ
Okay.
দিয়ে দিয়েছি। তো আমি যেটা বলছিলাম যে অ্যাটমসফিয়ার হচ্ছে একটা মিক্সচার অফ গ্যাস। হ্যাঁ, সে কি কি গ্যাস আছে? হ্যাঁ, I was telling that atmosphere is a mixture of gases surrounding the Earth's surface. What are the gases are there? It is given in this table. Major gases: nitrogen, oxygen, water vapor, carbon dioxide, methane, nitrous oxide, ozone. Major gases is not by your amount only. Major gases is mainly based on their role in the atmosphere actually. Water vapor, carbon dioxide. So what role they are? Oxygen to we can understand, because without oxygen to we cannot live. Water vapor and carbon dioxide, actually what happen, you know, both of them can absorb the solar radiation, outgoing solar wave radiation, and it can actually disturb the budget of the heat in the atmosphere. Similarly for methane also, and nitrous oxide actually related to pollution, and ozone for two reasons. One is for absorbing your ultraviolet ray. At the same time, excess ozone, if it is there, then it is a cause. It is an air. It hampers the air quality also. So this is your atmosphere, and these are the different layers of the atmosphere. Okay. So lowermost is troposphere, then stratosphere, then mesosphere, then thermosphere, like that actually. But we all are living in the troposphere. Troposphere is most important. So these are the different characteristics of the troposphere. Here 75 to 80% of the atmosphere is there. Most of the clouds weather forms in troposphere only. And in the troposphere only, maximum water vapor is available. It is wettest layer. And in the troposphere, your bottom is warmest, and as one goes up, temperature decreases. And I discussed that why temperature decreases, two physical processes, and pressure and density of the air, this is also decreases upward. Okay, which is the upward altitude up to, and it decreases upward to the tropopause. Tropopause is nothing but it is the boundary between troposphere and stratosphere. And now this is the thermal structure, vertical thermal structure of the atmosphere. We can see that in the troposphere temperature decreases. Then in the tropopause it is almost isothermal, no change. Then in the stratosphere temperature increases. And what is the increase? Why troposphere, in the troposphere temperature decreases, I already discussed. And why in the stratosphere also temperature should increase, that also I discussed. Because in the stratosphere or ozone is there, ozone absorbs the ultraviolet part of the solar radiation, and it becomes the air, what is called source of heat. And then mesosphere, it behaves similar to troposphere, and after that temperature increases. Okay. And next I was discussing about different physical processes. Physical processes, let us say, actually in typical scientific term, we can say these are all thermodynamic process, these are radiative process. In the thermodynamic process, one thing, heating and cooling, because in the atmosphere we can see somewhere heating is taking place, somewhere cooling is taking place. Then adiabatic process I discussed. It is a process where no exchange of heat is taking place actually. And considering the availability of the water vapor, we can say some adiabatic process is dry, some adiabatic process is moist, and Saturation I was just discussing with a joke of this Thakur Mosai. So when the Thakur Mosai will say, Bas, that means Thakur Mosai has been saturated. So in the atmosphere also, when one air sample is said to be saturated, when that air sample cannot contain more amount of water vapor, then we can say it is saturated. Okay. Now saturation can be done by two methods. Let us take that example itself. One method is that my mother may continue preparing puri unless the Thakur Mosai gets fully saturated. This is the normal way. Another one way, suppose if my mother plays a naughty that, okay, no, so many, she knows that Thakur Mosai will not become tripto unless he consumes about 50 or 60 luchi. And to prepare 50, 60 luchi for Thakur Mosai, that means my mother has to prepare at least 100 or more luchis because other members in the house are also there. So my mother may think of a tricks that Thakur Mosai should be satisfied with only 20 luchi. So what she can do that before start of, just like nowadays we take the starter. So before starting the normal luchi, then kumro choka, she can provide one starter, and that starter may be beguni, big aloo chop like that, or some singara, and after that let him consume one glass of water. 100% sure, immediately we all know very well what will happen. So in that case, for the Thakur Mosai, it may not be possible to consume that 60 luchis. He may stop even after 20 luchis. So that means you have made the Thakur Mosai saturated at the lower amount of this thing, by with the lower amount of luci actually. Here also, for saturation, one thing we know that certain amount of water vapor must be present at a given temperature. Then only it will be saturated. So now suppose let us take one air sample at some temperature having certain amount of water vapor. And the table, which we call hygrometric table, that table says that at this temperature, the Thakur Mosai, that means that air sample is not saturated with this much amount of water vapor. So then there is one way, okay, provide more water vapor. Okay, more water vapor we can provide. More water vapor provide, and after some time it gets satisfied. This saturation process, we call it an wet bulb process. That means whatever required water vapor is there, that additional water vapor is provided. But another one case, no, it is not possible. So then we make a back calculation. What back calculation? Then we take this amount of water vapor is fixed. At what temperature this amount of water vapor will make the our Thakur Mosai, that means that water vapor saturated. Tables, from the table we know, and another one thing is also there. This also we all know. Just I am repeating only that as the temperature increases, water vapor holding capacity increases. In a reverse way, I can say, as the temperature decreases, water vapor holding capacity decreases. So therefore, what I can do, its temperature should be decreased. That means that air sample needs to be cooled to certain temperature, at which the existing water vapor is just apt to make the sample saturated. This is also a process. So this process also named as a dew point process. Dew forms in this way. And once saturation is done, then after saturation, if you give, then what will happen? We can know. Suppose my belly is filled, but still I am being forced to eat. Then what I will do? I will precipitate. I will precipitate. That means I will vomit something. I will precipitate. That is condensation. After saturation, it will be condensation, and then condensation is also another one process. That is your water vapor. After saturation, if you give, then it will be saturated. It will be precipitated in terms of water vapor. Sorry, water droplet. Water droplet, that is condensed. And the process by which this water vapor gets converted to water. Actually, condensation is one of the process of phase change. We all know that matter has basically three phase broadly: solid, liquid, and this thing, water vapor. So now when I go from vapor to liquid, then that process is known as condensation. And just reverse thing, that is from liquid to vapor, then it is evaporation. These are the different thermodynamic processes are taking place in the atmosphere. There are many radiative processes are there. Radiative process in the atmosphere includes absorption, emission, scattering of the radiation by gases, aerosols, clouds, or surface. Absorption is what? Gases, aerosol, clouds, droplets, water, cloud droplets, ice crystal, they absorb radiation. Because every body actually in the physics there is a subject, the topic is there, radiation. Actually that radiation says that every body at a given temperature, it absorbs as well as it emits also some energy. What my point? So it absorbs radiation. Earth, surface of the earth is the most important absorber. This I already told of the solar radiation. Emission, once I absorb, I have to be, that means in Bengali we used to say, good data should be a good grohita, like that actually. So emission is means data. The gases, aerosols, cloud droplets, ice crystal, they emit also thermal radiation. And the surface of the earth emits heat into the atmosphere through infrared emission. Then scattering is also there. Scattering is means what happened that if the entire surface of the body of the substance, if it is not exposed, then in that case some part it will absorb or emit, some part will not be there. So this is actually scattering. Aerosol, cloud particles, and air molecules, they all scatter radiation. And reflection too, you all know that different surface, they reflect some radiation. It is not entered. So these are the different radiative processes are also taking place in the atmosphere. Okay. So next is your global pressure and wind pattern. This actually you all know because you are all expert in geography. In the geography, these are there. So I am not explaining this thing. These are known thing. Now let me come to some, that is weather elements and different instruments used to measure the weather elements. Let us discuss. First of all, if someone asks me, what is weather? So weather actually it is nothing but that is the condition of the atmosphere at a given instant of time at a given place. At any time, at a given instant of time, what is the condition of the atmosphere? What is the condition of the atmosphere at a given place at a given time? And now condition of the atmosphere is expressed. We all know very well how hot it is today, how humid it is today, how wet it is today, whether it is a dry day or it is a rainy day. Okay, like that. So therefore we can understand that condition of the atmosphere at any time we are trying to express in terms of value of the temperature. Am I correct? Then value of relative humidity, value of the rain, etc., etc. So that means condition of the atmosphere, at a place given time, it is expressed in terms of some meteorological, some atmospheric variable. These are actually basic atmospheric variables. Okay, which are continuously monitored, continuously observed, continuously monitored. And what are those? They are actually your pressure, atmospheric pressure, then atmospheric temperature, humidity, wind, rainfall, etc. So according to weather elements are this thing actually. And another one thing that this since the atmospheric condition, which is expressed in terms of pressure, temperature, humidity, etc., etc., and it changes with time. We all know very well. Changes with every place. It changes with time. And that change is not random. Change of every such parameter. Suppose if I consider the change of temperature also takes place following some physical law, well-defined physical law. Change of humidity, this is also like that. Change of pressure also. All the basic meteorological variable through which the condition of the atmosphere at any time, at any place is expressed. That means weather condition is expressed. All of them changes with time following some physical laws. And when any such system, changes with time following some physical laws, then such system we call it a dynamical system. Okay. So now next thing is these are the different in our India there are about 4 seasons are there, meteorological seasons are there. That in those seasons, these are the different types of weather phenomena. For example, January, February, which is winter season. We all know January, February, our weather system is western disturbance, Paschimi Jhonja, which we call, then cold wave, Shaitya Prabaho, then fog, heavy snow, frost. These are all your weather events. Then pre-monsoon season, March to May, still it is going on. Pre-monsoon season, one important weather event is cyclonic disturbances. We call it cyclonic storms, cyclonic circulation, etc. Then, of course, we all know very well, heat wave, then thunderstorm, squalls, we all are seeing nowadays, then hailstorm. These are all your major weather events and which causes natural hazard also. Then comes monsoon season, June to September. So what are the weather events? Heavy rainfall, then floods, and somewhere less due to deficient rainfall on drought-like condition. Then comes October, November, December, post-monsoon season. In the post-monsoon season, one thing is cyclonic disturbances taking place, and at that another thing is northeast monsoon, that is heavy rainfall also there. So these are your these are your weather events throughout the year in our country. So now let us come to the different instruments used to measure all these basic parameters. What are those basic parameters? Atmospheric pressure. What is it? It is nothing but the weight. Suppose you consider any point in the atmosphere, and you want to know what is the pressure at that point. At that point, you have to erect one column, or rather you can say it is a right circular cylinder, okay, which is extended up to top of the atmosphere. That means beyond that nothing is there, no mass is there. But you remember that cross section of that column should be unity. That is 1 square meter, 1 square centimeter, like that. And then in that column, whatever air is there, its weight, this is your atmospheric pressure. So therefore you can understand very well. Suppose that means if the pressure at your ground is something, then if you go 2 kilometers above the ground, definitely pressure will be reduced, because in that case that column is getting reduced by this 2 kilometer height. Okay, so therefore in this 2 kilometer lowermost 2 kilometer, whatever air is there, its weight is not included here. Okay, so as a result of which, when you are going to 2 kilometer, pressure will be less. So due to that, pressure decreases with height, you can understand. Then wind is nothing, we all know that is air. And what is the instrument? We are using barometer, baro switch, barograph. Nowadays barograph is there. Okay, then wind is there. Wind is air in motion over the surface, above the surface. So for that, actually we are having wind vane anemometer, and density anemometer is also there, which gives you pressure and wind both. Dynes pressure type anemometer. Then comes temperature. Temperature is nothing but thermal state of the atmosphere, that is whether the hot feelings, cold feelings, it is indicated by the temperature. Hot feelings and cold feelings you can mark in terms of temperature. So and we all know that for that actually we are using thermometer. There are actually 4 types of thermometer is there. When one is your dry bulb temper thermometer, one is your wet bulb thermometer, one is your maximum temperature thermometer, another one is your minimum temperature thermometer. Then humidity is nothing but it's a measure of the availability of water vapor in the atmosphere. For that, instrument is hygrometer. This is the instrument, hygrometer. Hygrograph, here hydrograph is also there. Now it is automatic, here this here, that is called hygrostat. Then precipitation actually, it is the product of condensation. It may be rain, it may be snow, it may be hail, it may be sleet, etc. For that actually rain gauge is there, snow gauge is also there. Then sunshine recorder is also there. It refers to the energy received from the sun, how much radiation we are getting. For that sunshine recorder is there. And then it is the cloud, which refers to actually how much my sky above is covered by how much amount of cloud. In terms of octa we represent. For that ceilometer is there. So these are the different instruments. Now regarding the cloud, something I can discuss. Cloud is nothing but it is a hydrometeor, which consists of minute particles of liquid water or ice or both, suspended in the atmosphere and usually not touching the ground. And it may also include larger particles of liquid water or ice, as well as non-aqueous liquid, that is, and solid particles such as those present in the fumes, smoke or dust. Then comes another one important parameter, that is freezing level. Freezing level is the level in the atmosphere where the temperature is 0 degrees centigrade. For every station there is a freezing level. Every station there is a freezing level. That means at what height temperature at that place is 0 degrees centigrade. Now air temperature below the freezing level is definitely more, and above the freezing level it is less. Now whenever there is a cloud, we all know very well, it has a top, it has a bottom. You may find some cloud whose top and bottom both are above the freezing level. Cirrus type of cloud, it is an example for that. And in such clouds, definitely what we can expect, more than water droplet, we can expect your ice crystals there. So these are this type of cloud is known as cold cloud. You see another one type of cloud also, whose top and bottom both are below the freezing level. So that means at any part of the cloud, temperature is above 0 degrees centigrade. This type of, generally in monsoon season, whatever cloud we see, generally, nimbostratus, this type of cloud, these are your warm cloud. This type of cloud is known as warm cloud. But at the same time, you can get another type of cloud, which also we know very well. It is a tall cloud whose lower part or base, cloud base is below the freezing level, but the top is above the freezing level. So this type of clouds, we can say these are called mixed cloud. Okay, thunderstorm clouds are like this. Besides, cloud can also be divided into high cloud, medium cloud, low cloud, considering the height of the base. And considering their texture also, cloud can be divided. Also, you know all these things. Some clouds are hook type, hook shape. These are called cirrus cloud. Some clouds are just like cauliflower type, that is cumuliform cloud. And some clouds are just like bed sheet type, that is stratiform cloud. Now, just a minute. These are different cloud classification is there. Now, precipitation mechanism. How sometimes we say precipitation. Precipitation refers to rainwater, ice particle, hail particle, etc. What are the precipitation mechanisms are there? One precipitation mechanism for the warm cloud is collision and coalescence mechanism. Now, first of all, we have to remember one thing. At a place, cloud can be formed if at that place there is some updraft, that is upward motion is there. Otherwise, it is not possible. So, when air is being lifted, and that air also contains certain amount of water vapor. Then that means when air is lifted, water vapor is also lifted. Now, as it is being lifted, water vapor gets cooled, and then at some temperature, water vapor becomes so cool that it condenses into water droplet. Initially, droplet sizes are very small, and these droplets are very light also. They just float in the cloud. They cannot come below. So, and now what happened, you know? For that, actually, I want to give one analogy. I hope that many of you must have seen that bodyguard line police ground. Now, in the bodyguard line police ground, you just live about hundreds of small kids and tell them just to run randomly, just to run. And while running, if you collide with another one kid, then instead of fighting, both of you embrace yourself. And then in the embrace condition, you continue running. And again, when you hit another one child, again you embrace that child also. So now single childs, these are nothing but small droplets. Droplets are having random motion, they are moving. Okay, and these droplets are colliding during their motion, and once collide, they coalesce, they just embrace themselves. Embrace themselves, coalesce. And this collision and coalescence process, it continues until the droplet become sufficiently bigger, larger, so that it can no longer float in the cloud. Then by gravity, it starts falling. Okay, so this is known as your collision and coalescence mechanism. This is only written here. And another one mechanism is also there, that is known as Bargerian method. Bargerian method, this is for the cold cloud. In the cold cloud, as I told you, there is a coexistence of supercooled water droplet. Supercooled means water droplet at minus 40 degrees centigrade or below. These are called supercooled water droplet. And at the same time, there are ice crystals are also there. Now, as per from the physical laws, we know that water vapor pressure over supercooled water droplet is more than the water vapor pressure over the ice crystal. Actually, there is a coexistence between supercooled water droplet as well as tiny ice crystal as well as water vapor also. This also I should have mentioned. So now, so therefore, you are having one ice crystal and you are having one supercooled water droplet. Water vapors are there above that. Now, water vapor over the ice crystal is lesser than the water vapor over the supercooled water droplet. And we always know that flow is always from the higher pressure to lower pressure. So therefore, what will happen? Water vapor will flow from the ice crystal to from the supercooled water droplet to the ice crystal. In this way, ice crystal will grow at the cost of the supercooled water droplet. And ice crystal will grow. And when the ice crystal grows sufficiently large so that it can no longer remain, then it falls down. So these are the two broad mechanisms are there, okay, for the precipitation formation. So now another one thing also, we are all common man. Many times we see over me, there is a very big cloud is there. Very big cloud is there, okay, but thing is, there is no rain. Ultimately, rain did not come at my place. Rain did not come. So for that actually, this slide explains that what are the different factors deciding whether a raindrop will reach at the surface or not. They are actually, I am now drawing something here, okay. Suppose this is your surface, and this is your cloud. This is the base of the cloud. Suppose this is an water droplet. It leaves the base and it started falling. Now this is the cloud base, this is the surface. This layer has a name. This is called subcloud layer. It is known as subcloud layer. Now, if the subcloud layer is very, very dry, then that means what I say, if the relative humidity in the subcloud layer is sufficiently low, then in that case what will happen? While falling, in the midway itself, entire water may be evaporated. It became completely dry, so you will not get. This is number one. Number two, that suppose the depth is more. This depth is more. Now, when this is started falling, it is having some momentum, isn't it? Now, question is, if this fellow is too weak to travel so much path, then what will happen? In between, it will be dry. This is number two. Number three is suppose it is falling. It is falling. But suppose if there is a strong wind, then what will happen? This fellow may fall somewhere else. You are expecting here, but it falls there. So this is known as drifting. So these are the different factors. I hope this is clear. These are the different factors which decides whether a raindrop will reach the surface or not. Then another one thing that definitely that what are the different factors for change of temperature at a place. what are the different factors? The mechanism for change of temperature. Temperature at a place changes due to local effect and the wind effect. Local effect I am just trying to explain. Let us consider my station itself. And at my station today is certain temperature is there. At my station certain wind is there. And today I find at my station, over my station, there is 6 octa cloud is there. Let us come to tomorrow. Tomorrow, wind conditions same, all the other conditions same, but the cloud condition change. It is from 6 octa, it becomes 2 octa. Then in that case, what will happen? In that case, what will happen? Because what is the role of the cloud? Because when cloud is there, then from the Earth's surface, whatever radiation is emitted upward, a part of the emitted radiation, part of the emitted heat, you can say, it is getting trapped by the cloud. That means more the cloud, more the trapping. Trap means heat cannot go above, heat remains within our atmosphere. That means we will feel more warm. But if the cloud amount reduces, then what will happen? Then naturally some amount of heat will go. So therefore temperature will down. So this is your local effect. Okay, due to the change in the incoming solar radiation received in the survey, this is mainly controlled by the local heating, cloud and aerosol also. Local heating results in increase in temperature, local cooling results in decrease in temperature. That is for that cloud I have already told. Aerosol also like this, incoming solar radiation. In this case, incoming solar radiation itself get intercepted. Incoming solar radiation interacts with the aerosol and it results into different radiative process. Just like some amount of solar radiation may be absorbed by the aerosol, some amount may be emitted back upward, some amount may be scattered here and there, which results in a net effect on the incoming solar radiation. So, and if the solar radiation received is less and more, automatically outgoing will be less or more, and naturally it will have a effect on the temperature. So that is, these are your local effect. Wind effect is what? Just suppose today at my station where temperature is say 30 degrees Celsius, and suppose at my station wind is blowing coming from a station, from a region where temperature is 35 degrees centigrade. So then in that case what happened? Warmer air will be brought at my station, which will result in increase in the temperature. This is wind effect actually. Okay. Example also I have shown. That's why when a place wind comes from northern latitude, relatively colder, then temperature decreases, and if it goes from southern latitude, temperature decreases. And humidity of the place also due to the way, in the same way actually. Now, what are we all know very well that these are the different significant weather affecting our West Bengal state. One is your severe local storm, thunderstorm, swell line, etc., lightning also. Then another one is your cyclonic storm. Then another one is monsoon, heavy rain. Then heat wave and cold wave. Thunderstorm, we all know that it is a rain shower during which thunder is heard, and it comes from the lightning. All thunderstorms, they are having lightning, and it is a result of convection. That means air becomes heated and it just moves up. Okay, a thunderstorm is classified as severe when it contains hail of 1 inch or greater, winds with gusting in excess of 50 knot. 50 knot means 57.5 meter per hour for a tornado. For the thunderstorm to develop, many times people may be asking, we all may be curious that why thunderstorm is not taking place. Because for thunderstorm, for to take place, certain atmospheric conditions are necessary. What are those things? One is your strong surface heating, so that the air in contact with the ground, it gets warmer, lighter, and it gets lifted. Number one. Number two, that air must be moist, which is indicated by the very high value of relative humidity, that is 75% above. Because if the dry air rises, it has very less, it will not give you any weather. Then thing is instability. Instability is expressed in terms of the change in temperature with height. Already we have seen that in the troposphere, temperature decreases with height. The rate at which temperature decreases, it has a name. It is called lapse rate. It is called lapse rate. Now, this lapse rate should be 6.5 to 7.5 degree Kelvin per kilometer. And there must be some lifting mechanism available, because some lifting mechanism is required. Some lifting, up to certain height you have to lift, you have to give a support for lifting of the air, surface air. After that, air can move on its own way. Okay, so there are many lifting mechanisms. Are there, like mountain slope ascent, then your upward motion of converging air. Suppose if the air converges at a point, then it gets uplifted. And then when different type of air mass, air mass with different physical property, if they meet, then their surface of the meeting surface, we call it front, that frontal upgliding. These are all required. These four things are required. In some day you may find all the three things are there, but this one is not there. That's why you will not get. Someday you may find that thunderstorm takes place, but rain was not there, because a moisture available may be less. All these things are there. Okay, someday you may find that instability is there, but it is not very high. So that means cloud development, you are not getting very tall cloud you are not getting. That means hail you are not getting, but someday you may get. The different conditions thunderstorm to take place. For the thunderstorm, there are different stages are there. One is developing state, where only rising motion of air is taking place. Another one is your mature state, in which one rising motion, another one sinking stage, and another last stage, that is decaying stage. At this stage, only strong takes place, strong down-up takes place, is a decaying state. Next thing is, there are different impact of severe local storm that we all know, we all faced also. One is your strong wind. Strong wind has a very severe impact, we know, because in the due to strong wind, what happens, many object flies, and if the objects are very sharp, then it may harm animals, human body, etc., who are being exposed. Then heavy rain also. Then hailstorm. Recent hailstorm, during hailstorm, hails may be sufficiently larger, and those hails, if it falls on the roof of the car may be damaged. If it falls over asbestos roof may be damaged. All these things. Okay. And not only that, it may even suppose at one place, small birds are being kept, and if a big hailstorm falls on it, birds may be killed also. Recently, I have seen this type of things happen at Balasore region. And then lightning, we all know very well. Nowadays, in our eastern region, throughout India itself, lot of lives are being taken due to this lightning event. And there are many forecasting techniques are there. And it is a lightning, we know, it is a giant spark of electricity in the atmosphere between the clouds and the air, or between the cloud and the ground. Okay, when cloud to air is there, then cloud, this is not, it is not that much dangerous than this one. In the early stage of the development, air acts as an insulator between the positive and negative charges in the cloud. In the cloud, actually, different types of charges are developed, and air acts as an insulator and between the ground and the cloud. When the opposite charges build enough, then the insulating capacity of the air breaks down, and there is a rapid discharge of electricity, which we know lightning, and the flash of the lightning temporarily equalizes the charged region in the atmosphere until the opposite charges build up again. And lightning can occur between opposite charges within the thunderstorm cloud, intra-cloud lightning. This is called intra-cloud, within or between opposite charges in the cloud on the ground. That is cloud to ground lightning. It is more dangerous. Next thing is we all know, we all are experienced in West Bengal, that is a cyclonic storm, which is nothing but an intense low pressure system where the maximum sustained wind is 33 knot. 33 knot you can multiply by 1.6, I think. Then we can get the kilometer per hour. Okay, and cyclonic storm, for the cyclonic storm, everywhere you cannot get cyclonic storm in the world. Cyclonic storm forms over certain region which are known as Genesis region. They are generally over the warm tropical oceanic region. So for the cyclonic storm, warm ocean is very much required away from the equator, where moist air converges and weak vertical wind shear prevail. And then spatial extent is horizontal extent of a well-developed cyclonic storm is of the order of 100 to 1000 kilometer, and its vertical extension is 10 kilometer, above 10, more than 10 kilometer. Now the classification of the low pressure area, when initially it forms just like a low pressure area, we all know, and its associated wind speed is 31 kilometer per hour, or less than 31 kilometer per hour. And when it becomes a depression, then it is 31 to 49 kilometer per hour. When it is deep depression, 50 to 61 kilometer per hour. Cyclonic storm 62 to 88. Severe cyclonic storm 89 to 117. Very severe 118 to 167. Extremely severe 168 to 221. And super cyclonic storm, Amphan we had, that is super cyclonic storm is more than 222 kilometer per hour. Now for one place, I told you that cyclone takes place over tropical ocean, but everyday cyclone is not forming, no. That means even over the Genesis region also, for the formation of a cyclone, certain conditions are required. One is it requires warm ocean, and this warm ocean is not on the ocean layer, that is a surface layer. This warm ocean, warm temperature must be there at least up to 50 meter depth. Then there should be a relatively moist layer in the middle troposphere. That means up to 5 kilometer, there should be humidity should be good. Then it must be away from the equator. It must be away from, it should not be over equator. It must be a little bit away from the equator, so that Coriolis force we all know Coriolis force is minimum, and then there must be some pre-existing disturbance must be there, and then vertical shear of the horizon. That means difference of the low level wind and upper level wind should not be very high, it should be less. And of course that layer should be unstable layer. In term unstable layer, I already discussed, that is your lapse rate. Lapse rate should be about 6.5 to 7.5 degree Kelvin per kilometer, like this. If now you consider a cyclone, you just cut the cyclone horizontally, then you will find actually three stage, three stage, not three part. One is you will get the eye, okay. This is the eye you will get, okay. Then another one, wall cloud region, and then outer wall you will get. This is eye region as seen from the radar. Most spectacular part of a mature cyclonic storm is the eye, which forms at the center of the storm inside a central dense overcast region. This eye has a diameter of about 10 to 50 kilometers, which is generally cloud free and is surrounded by thick wall clouds around it. And it resembles an eye when viewed in a satellite picture. And it is relatively a calm region which practically no rain, and it is warmer than the surrounding region. Why it is warmer? Because in the eye region sinking motion takes place, and when air sinks then there is a compression, and due to compression there is a heating. That's why eye region temperature is more than the surrounding area. And after the eye, then there is wall cloud region. This is the most dangerous part of the cyclonic storm. Its height goes more than 10 kilometers. Intense convection takes place in this wall cloud region, and the storm surge associated with cyclonic storm, this occurs in the eye wall region only. And the exact position of this eye wall is identifiable from cyclone detection radars, as the radius of the maximum reflectivity of the radar beam coincides with the radars of maximum wind in a cyclonic storm. After that, actually, outer wall. Spiral bands are sometimes hundreds of kilometers long or a few kilometers wide. The spiral bands are easily identifiable in radar and satellite picture. You can see here it is shown, okay. And these spirals also continuously change places and orientation with respect to the center and rotate around it. And this region is beyond 250 kilometers from the center. And weather conditions in the outer storm area are better with scattered cumulus growth of interspersed with spiral band. This is your horizontal structure. At the same time, you can have a vertical structure also. Vertical structure, that is lowermost layer, this is called inflow layer, then middle layer, then your outflow layer. In the inflow layer, only inflow takes place. And in the middle layer, actually there is no inflow, and the outer layer only outflow takes place. Okay. And cyclone has as in general, it has a life cycle. One is your formative stage. It covers the period from a genesis of a cyclone, that is through low pressure, depression, deep depression. Then immature stage, I can show you the picture, that will be better. No, picture is not there. It was there, I don't know. In the immature state, the central pressure of the system continues to fall till the lowest pressure is attained and wind speed increases. In the mature stage, no further fall of pressure and increase in the wind speed. And decaying stage, tropical storm begins to lose their intensity when they move over the land and over colder area, or lie under unfavorable large-scale flow. And now this we may skip also, but anyhow I am not skipping because many of you may be interested. In a total wind field in a tropical cyclone, there are two types of circulation. One type of circulation is like this, we all know very well. It is in the low level, it is like this, and at the upper level it is like this. Outflow, low level it is inflow. This inflow and outflow, these are known as primary circulation. But at the same time, if you consider this is the eye, and these are your wall cloud, Then what happened, in the wall cloud region, rising motion takes place. Wall cloud region you may find on both sides of all sides of the eye. So only two sides I have shown. Rising motion takes place first. Then after rising certain height, it loses its vertical momentum. Then it spread, spread, and then spread means it is divergence, outflow, and then it falls, sinks, and then it goes here. Same thing is here. That means in, up, out, down, in, up, out, down. This is known as secondary circulation. And both the circulations are important, right? Both the circulation, one circulation maintains one physical property, that is your momentum, angular momentum. Another one is your energy. Then in the cyclone, also you all may be knowing there is a Fujiwara effect is there. Sometimes referred Fujiwara interaction between two nearby cyclones actually, okay, each other, and close the distance between them. Now when two cyclones are there, then between the two cyclone center you can find out one centroid, actually center of mass. Around that center of mass, both the cyclone center, it rotates actually binary. So this is called Fujiwara effect. And these are the high impact weather: strong wind, heavy rain, storm surge, lightning related to cyclonic storm. Then comes your southwest monsoon rain. Is from June to September. Our Bengal will know normal date is 10th June. What are the rain bearings weather phenomena? First is a strong monsoon current. Second thing is low pressure system. Low pressure system means well marked low pressure area, depression, deep depression, etc. over North Bay of Bengal, and its northwestward or west of northwestward movement. Then your mid-latitude westerly trough and western disturbances and their favorable interaction with the monsoon. Then monsoon trough, we all know very well, it passes through Kolkata and Asansol. Then normal or south of the normal position of the monsoon trough, that also plays a very important role. If the monsoon trough is south of its normal position, then we get a good amount of rainfall. But if it goes along the foothills of the Himalaya, then Himalayan region they gets good rainfall, but remaining part rainfall is very less. Now there are different extreme weather associated with temperature. One is our heat wave, cold wave. We all know very well. It is based on the maximum temperature recorded at a station on a particular day and its excess from its normal value. Okay, summer season it is there. According to that, we define moderate or severe like this. Similarly, for the cold wave, also it is based on the minimum temperature, and how the observed minimum temperature is below the normal minimum temperature at a place. Accordingly, cold wave is declared. It may have different degree of intensity, that is light, moderate, severe, etc., depending on the magnitude of the deficit of observed minimum temperature below its normal value. During winter season, excess cooling at a place due to reduced solar heating or due to bringing of colder air, all these things can give rise to cold wave. Similarly, during summer season, excess of heating at a place due to enhanced solar radiation or due to bringing of relatively warmer air, etc., they are responsible for heat wave at a different degree of intensity. Okay. And now comes to climate element, climatic control at a place. Climate is nothing we all know now. It is a long-term statistical average of the climatic atmospheric condition. And there are different climatic elements are there. These are similar to our weather element only. That is temperature, humidity, wind, pressure, rainfall. But there is one important concept is there in climatology, that is called climatic control of a place. There are a few climatic controls are there. One is your latitude, then longitude, then altitude, proximity to the sea, and presence of orography. These are all climatic control. Actually, what I mean to say, all this thing controls the climate at a place. At the same latitude, if one is stationed at mean sea level and one is stationed at about say 3 kilometers above the mean sea level, so naturally climate will be different. Naturally, that climate will be different. It will be colder, it will be drier, etc. Similarly, at the same latitude, if one is stationed near the sea and one is stationed inside the land, that is inland, so naturally there will be different type of climate. We all know very well. And climate at a place is determined by the climatic control. And climatology is what we can understand. It is a study of the atmospheric condition prevailing over a period, prevailing at a place over a long period of time. Now, climate system and its climate system is a very important concept. It is defined as an interactive system which consists of a few major components. 5 major components are there. One is your atmosphere where we are living. One is your hydrosphere, means all water thing. Cryosphere means all ice things. Then land surface, then biosphere. These are in the picture also. It is shown that climate system and their component. This interaction is very, very important thing. Then comes that many of the students, they may know how weather forecast is been. What is weather forecast? Weather forecast is nothing but it is a technique to tell what will be the future atmospheric condition, weather condition at a place at a given time. Now, for that actually, one thing we have to remember, we must, suppose if I want the weather forecast of Kolkata for tomorrow, it is what? That means I want it, that means I need to tell what will be the weather conditions over Kolkata tomorrow. For that, I must have a thorough knowledge, full knowledge rather, about the today's weather, present weather over Kolkata. Without that, it is not possible. And meteorological fraternities, if they are committed for the weather forecasting. Now, for the weather forecasting, actually many things are needed. One is very qualified, trained human resource and very robust observational system network, which includes surface manual observations, upper air observations, automated observational system like AWS, ARG, etc. Then tool for remotely sensed observations, satellite and radars. Then means of exchange of communication. Now, without a good communication method, weather forecasting cannot be effective. Then computational capability is also there required. And we must have a very good platform for analyzing all the available informations overlaying on each other. Okay? An effective display system. These are some basic needs. And what I was telling you, a very observational system. These are the different components of the observational system. Surface, upper air, marine, aircraft, it is shown in this picture. This is known as global observing system. You can see this is a typical observatory. What my point? Satellite, okay, by balloon, all this thing, then ship, then marine, ocean buoy, etc. Satellite, both type of satellite, then aircraft. So, and any other platform also. And there are different types of weather forecasting methods are there. One is synoptic method, one is statistical method, another one is your dynamical method, another one is your ensemble method. In the synoptic method, what we do, these are the steps we need to do. First of all, observations are taken over the entire globe simultaneously at some fixed time. We call it synoptic hours of observation. Then once observation we are getting, we prepare, the coded messages are prepared for the observed information. Then coded messages are exchanged among each other. Then after receiving the coded messages, they are being decoded. Then decoded weather element, decoded information about weather element, they are plotted on some charts. Charts means map as such. Okay? And then what happened? For every parameter, we draw the lines joining stations with same value of the parameter. When we draw lines joining stations with same mean sea level pressure, then we call it, it is an isobaric analysis, pressure analysis. Similarly, when we draw lines joining stations with equal value of temperature, we call it is an isothermal analysis. When we draw lines joining stations with equal value of relative humidity, we call isohygric line. Like that, actually, this type of lines are being drawn. And drawing of this type of lines is known as analysis of the charts. And while drawing of this type of lines, there are a couple of thumb rules are there which are very much well science based. Okay? And now once the analysis is completed, then it will be possible to find out some regions where that particular variables is having very highest value or the particular variable may have a least value. These are called synoptic features. A good analysis results in identifying the synoptic features very nicely, very correctly. And once the analysis is being done, the chart is being placed before the forecaster. Forecasters, using their knowledge, experience, training, education, etc., they know which synoptic feature is associated with which type of weather, and accordingly weather forecast is being done. So this is in nutshell the synoptic method of weather forecasting. Then there are another method is also there, statistical method. In this method, actually regression relations are being established between the variable to be predicted with the variables whose values are known to us. And then these equations, these regression relations are used for the forecast for the future time. This is your statistical method, and I would like to tell you that India Meteorological Department, we know that it is being giving long range forecast of Indian summer monsoon rainfall for a long time, and initially it was using the statistical method only, and nowadays also statistical methods are there, but every method has its pros and cons. Then nowadays, actually, whatever we do, that is a numerical weather prediction. In the numerical weather prediction, what happened? Numerical weather prediction, what happened? There is one basic realization is there that to know the weather at a place at a time, I must know the value of pressure, temperature, wind, density, and humidity at that place at that time. If I know, then I can tell what will be the specific weather phenomena. So for that, actually, in the numerical weather prediction, instead of attempting to forecast the weather, first it is attempted to forecast, that is to tell the future value of wind. These are the three components of the wind: north, south, east, west north-south wind, up-down wind, upward-downward wind, then temperature, density, pressure, and humidity. So these things are being attempted to predict. Now, for predicting their future value, there are certain rules are there, some equations are there, mathematical equations are there. Those equations are solved, and by solving, future values of all these things are calculated, and then using this thing, concern weather concern weather is being found, and in this way weather forecast through NWP method is being given. So we call it NWP model. We call it NWP model. This is the same thing written. There are many things are there actually. What are the actually it needs many things. One is your there must be all type of observation we must have. For that one big storage is there. Big storage is there where all types of observation comes. We call it global telecommunication hub. There is all types of data is there. Global telecommunication hub. All data come there. Now all those raw data, they needs to be pre-processed actually. Pre-processed are being done. Then after being pre-processed, this using this data, mathematical equations, as I told you, these are also known as governing equations. Those equations are solved. Okay, using that is high power computing system, using very sophisticated mathematical rules, mathematical method, and then after that, predicted future values of these 7 variables, they are being post processed according to the needs of the customer, in this case our stakeholders, and then accordingly our weather forecast of specific weather is being issued. Okay, now one thing we have to remember, forecast is forecast only. It is not possible to know the true value of any parameter. That means present value, it is required that complete knowledge about the present condition of the atmosphere should be known to us. But unfortunately, it is not known. It is not 100% known. There are some imperfection in the observation by any mean. This is nothing but an estimate, but it is we cannot say it is 100% error free. It is 100%. So observation is not perfect. Similarly, whatever equation we are using, in those equation also there are certain imperfections are there. One imperfection is there, that there are many physical processes are there which are responsible to change these 7 variables, that is wind, temperature, pressure, humidity. But those physical process we are not able to express very explicitly in terms of mathematical equation, mathematical terms. So so what we try to do, we try to make some approximation. So therefore there is some imperfection. So therefore you can understand equations are not. So that's why definitely what happened, there is always some uncertainty in a forecast, always. So now question is, so when it has been, this only I was telling, that there is some uncertainty in the forecast. There are some, because your model is not perfect, your observations are also not perfect, and question, another one is in the model's equation itself there are some intrinsic issues are there, due to which after few days perfection of the model just goes away. So this is a problem. That means there are uncertainties in the forecast. So therefore what happened, it is better to make an attempt to quantify this uncertainty in the forecast of the weather, and let us provide this information also to the stakeholders along with the forecast. That this gives the birth of another one system, that is called ensemble prediction system. In the ensemble prediction system, what happened, that instead of it is like that actually, I am showing you just one picture, you will understand. Next, yeah, look at here. These are the two cases. Now, in one case, what happened? Suppose there are many numerical weather prediction models are there for predicting a single weather system for a few single stations or single place for a given future time. There are many numerical models are there, and this is the initial observation. Using this initial observation, all the models generates their forecast. There are the two cases generate their forecast. F1, F2, F3 like this. Now, there may be two cases. In one case, it may be that all the forecast informations they are diverges from each other. There may be a lot of diversity. There is no agreement. But another word case, it may be like this. So one may be away but major informations there, there, major information, major information, uh, major information they are converging. So in this case, this uncertainty is less. In this case, uncertainty is in this case uncertainty is more. In this case, uncertainty is less. So now, if this information is provided to the customer, that is our stakeholder can very judiciously can use which should be used. Definitely, it will be used that time. This one. So similarly, this is also another one way of ensemble. So suppose you are having one initial observation, but from one initial observation, you can generate many initial observations. You may ask me, sir, how? Very simple thing. Suppose your initial observation for the temperature is 25 degrees centigrade. Okay. So now from the 25 degrees centigrade, you create lot of temperature. Say 24.9. 24.99, 24.999. Then here also you do 25.01, 25.001, 25.0001, like that. So in this way, you are having for a given parameter many initial value. How you have got that is in whatever initial observation you are having, you just disturb them. Technically, we call it perturbing the initial condition. So that you have created many initial conditions. Now, using each and every initial condition, and suppose you are having one model only, you run the same model using different initial condition, and you just see what result comes. You may have two scenarios, this scenario and this scenario. I need not to tell. In this scenario, uncertainty is less. That means reliability is more. Okay. So therefore, user can rely on it, user will not rely on it. So this is also now another one thing, ensemble prediction, and these are different IMD services that that you may be knowing, that it gives the service to the general public, disaster manager, stakeholder, etc. That may not be very much important for the. These are also not important. These are also not important. And this may be useful for our student. Climate change nowadays, it is a very, very important thing. Now, climate change refers to the long-term change in temperature and weather pattern. There are now how I will know that climate change has taken place. For that, some indications should be there, na? So there are certain climate change indicators are there. One is in the temperature and energy field, surface temperature, ocean heat content. Then atmospheric content. I will show you the picture. Then you will understand. You see, ocean heat content, it is increasing. Look at here. Okay. Then your surface temperature, near surface temperature, this also increasing. Look at here. Okay. So this is one. Then another one is a global average sea level. There is an increase. Then Arctic summer sea ice extent. You see, this is declining. And here carbon dioxide concentration, this is increasing. So these are all the indication that climate change has taken place, it is taking place. What are the signs of the climate change? Atmosphere, at one is your atmospheric greenhouse effect. One is your reflectivity or absorption of the Earth's sun's energy. Then changes in the Earth's orbit or rotation is not so important. Then variation in the solar activity, this is also not. Then changes in the Earth's reflectivity, volcanic activity, changes in naturally occurring carbon dioxide concentration. We have no control in the last few, but definitely we have control on this thing. Okay, we are responsible for this also. So atmospheric greenhouse effect, everybody of you know that there are certain gases which has the capacity to absorb the outgoing radiation from the Earth's surface. So now if such gases and which makes now actually whatever this is required also. This is required also because had there been no such gases, then our atmosphere would become very very cold. Meaning it is not worth for living. So since the greenhouse gases are there, that's why it is livable with greenhouse gases. But now question is, if that so quite naturally, if the greenhouse gases increases, then in that case, we all can understand that outgoing solar radiation it will be less. That means more and more heat will be trapped in the atmosphere and it will be warmer. Then there are many effects of the climate change on the local climate. One is your increase in the frequency and intensity of extreme weather event. It is happening. We all know that is heat wave, rainfall deficiency or flooding, etc. Then increase in the rapid intensification of cyclones. Nowadays it is happening. Then forest fire, urban heat island effect. Then shifting of the season, that is called climate shift, like that. Then effect of climate change, one is India is already experiencing an warming climate. We all know. Unusual, unprecedented spells of hot weathers are expected to occur far from frequently and cover much larger areas. West Coast and southern India are projected to shift to new high temperature climate regimes with significant impacts on agriculture. Then rainfall pattern. A decline in monsoon rainfall since 1950s have already been observed. The frequency of heavy rainfall events has also increased. From the experiment, it has been seen that the numerical experiment suggests, results of the numerical experiment suggests that 2-degree rise in the world's average temperature will make India's summer monsoon highly unpredictable. That is very, very dangerous. And at 4 degrees centigrade warming, an extremely wet monsoon that currently has a chance of occurring only once in 100 years is projected to occur every 10 years. 10 years by the end of the century, if 4 degrees centigrade warming is taking place. Now it is extremely wet monsoon year we are getting once in 100 years. But if 4 degrees centigrade warming takes place, then it may be to occur every 10 years. It will be more frequent. Then an abrupt change in the monsoon could precipitate a major crisis, triggering more frequent drought as well as greater flooding in larger parts of India. It is already we are witnessing India's northwest coast to the southeastern coastal region could see higher than average rainfall, and dry years are expected to be drier and wet years are expected to be wetter. These are some effect of climate change on the local climate. Then rainfall deficiency. Evidence indicates that parts of South Asia have become drier since 1970s with an increase in the number of years with rainfall deficiencies. In 87 and 2002, rainfall deficiency affected more than half of India's crop area and led to a huge fall in crop production. Rainfall deficiency occurrences are expected to be more frequent in some areas, especially in northwestern India, Jharkhand, Odisha, Chhattisgarh, and crop yields are expected to fall significantly because of the extreme heat by 2040. Then effects of the climate change on the local cyclones. Over the last 50 years, global ocean has absorbed 90% of the excess heat. generated due to man-made climate change, and this has resulted in massive ocean warming. Man-made climate change, one thing I am telling you, actually in some research paper it came out, that is actually now a lot of industrial effluent also goes to the ocean, along with plastic and other things. And now all those effluent and other material in the ocean, when it goes, different types of chemical reactions take place. Actually, in chemistry, we have read there are some reactions are there which which absorbs heat from the surrounding, and there are some reaction which release heat. So now this type of reactions which release heat to the ocean, this is also expected actually. It has been shown. So and then thunderstorm and lightning. Actually, more with climate change contributing due to climate change, we all know, and it is contributing to hotter and drier weather in some areas. So therefore, risks of wildfires sparked by lightning, that is dry thunderstorm, that is also very much expected. So, rising global temperature due to climate change means warmer air, which allows it to hold more moisture, roughly 7% moisture per 1 degree centigrade warming. And this boosts the chance of thunderstorm, leading to more violent storms and more lightning strike. Moreover, thunderstorms could result in an increased occurrence of lightning, including hot lightning. This is dry thunderstorm due to the dry thunderstorm, which can ignite wildfire more easily. Okay. Then coastal station, discomfort at the coastal station, that is also taken. Coastal stations also nowadays they are reporting heat wave. Coastal stations are known to have mild temperature in the hot season. For sea breeze adjacent to the ocean should bring cooler air. But due to human activities, ocean is absorbing excess heat of the atmosphere. Due to that, what happened? Ocean is becoming warmer, and consequently, sea breeze becomes weaker, and not only weaker, it is becoming very what is called it is not timely actually. It is not timely. In a changing warm climate, sea breeze continue to be weaker, and the discomfort level at the coastal station is likely to increase. Then sea level rise, that is a very well talked issue. Mumbai has the world's largest population exposed to coastal flooding, with large parts of the city built on reclaimed land below the high tide mark. Just you see, and rapid and unplanned urbanization further increases the risks of seawater intrusions. Sea level rise and storm surges would lead to saltwater intrusion in the coastal areas. It will impact agriculture, degrading the groundwater quality, it will contaminate drinking water also, and possibly cause a rise in diarrhea, cholera outbreak, etc. Kolkata and Mumbai, both densely populated cities, they are particularly vulnerable to the impacts of sea level rise, tropical cyclones, and riverine flooding. Then glacier melting. Most Himalayan glaciers, where a substantial part of the moisture is supplied by the summer monsoon, have been retreating over the past century. I have shown the picture also. At 2.5-degree warming, melting glaciers and the loss of snow cover over the Himalayas are expected to threaten the stability and the reliability of the northern India's primary glacier-fed rivers, particularly Indus and the Brahmaputra. The Indus and Brahmaputra are expected to see increased flow in spring when the snows melt, with flows reducing subsequently in spring and summer. That means in the spring, flow will be more, that means there may be flooding in the Brahmaputra also. And then alteration in the flows of the Indus, Ganges, Brahmaputra rivers could significantly impact, we can understand, impact irrigation, affecting the amount of food can be produced in their basins as well as in the the livelihoods of millions of people. Thank you very much.
Thank you very much, sir, for your enjoyable and very, very lucid lecture. And I have enjoyed, and I think the students have also enjoyed the story of Thakur Moshai as air mass and Luchi as water vapor and Beguni as their given temperature. And I assure you that I certainly repeat this story of course with your name reference in my future class. Actually, both the college jointly has only 140 interns, but accommodation in Google Meet is only 100. So we have having the Facebook page live, and now it has become a boom to us because the enjoyable lecture will live in the cloud. And the example of kids running and embracing with droplets to light and fluorescent, and it is also a very good example. And our second sem students have not started with graduation level climatology, and when they will start, they are starting in the next semester. I advise and request them to listen to your lecture again and again, and actually to secure good marks. And I think for this lecture, the reach of our departmental Facebook page will also increase. So benefit is multidimensional, and your lecture is very, very according to CU syllabus. And you have given us a valuable insight for forecasting and the burning topic, the climate change. So again, very, very thank you so much, sir.
Thank you very much. If you,
Sir,
anyone having any question, I will be happy to reply.
হ্যাঁ,
just an observation.
ওই বলো যদি একটু বলো
Sir,
হ্যাঁ
sir,
বলুন
just one observation. Just one observation. I think the students and both the students and the teachers of our department and the department of Amta College, Geography Amta College are saturated, not only saturated, super saturated with your fascinating and lucid lecture. Thank you very much, sir.
No question. Thank you for your appreciation. But question, any questions from the student or anybody else?
I request the students তোমরা যদি কোনো কোয়েশ্চেন করো।
স্যার একটা বিষয় একটু জানার ছিল। আমরা মানে আমি একটা জায়গায় মানে কোনো একটা বইতেই পড়েছিলাম অ্যাডিয়াবেটিক ল্যাবসেট, আপনি যেটা সবার প্রথমে বলছিলেন ওই বইতে পড়েছিলাম অ্যাডিয়াবেটিক ল্যাবসেটটা থিওরিটিক্যাল, সেটা মানে রিয়েল মানে ওয়ার্ল্ডে রাইজিং অল্টিটিউডের সাথে এয়ার পার্সেল যে কোনো রকম টেম্পারেচার এক্সচেঞ্জ করবে না, এটা মানে ডিফিকাল্ট অর ইম্পসিবল। তো এটার রেলিভেন্সটা কি আমাদের পড়া?
না না, ওটা ব্যাপারটা হচ্ছে কি সবকিছুই ইররিলেভেন্ট। ফর এক্সাম্পল আমি বলছি কি যে সবসময় না একটা স্ট্যান্ডার্ড কনসেপ্ট থাকা অলওয়েজ বেটার। যেমন ফর এক্সাম্পল আমি যখন ছোট ছিলাম আমার বাবা আমাকে বলতেন রামচন্দ্রর মতো হওয়ার চেষ্টা করো। সব বাবারা চায় তার ছেলেরা যেন রামচন্দ্র, বাট উই অল নো ভেরি ওয়েল যে রামচন্দ্র আমরা ইয়ে করি, কিন্তু ইট ইজ অ্যান আইডিয়াল পিকচার অ্যাকচুয়ালি। আমাদের একটা আইডিয়াল পিকচার, এবং আইডিয়াল পিকচারটা কেন দরকার, কারণ তার থেকে কতটা ডেভিয়েটেড আছে সেটা জানার জন্য। অ্যান্ড ডেভিয়েশন হ্যাজ সাম এফেক্ট। Similarly, you may find, had you been an atmospheric science student, you would have came across many other concepts, just like barotropic atmosphere. Really, there is no barotropic atmosphere at all. But we always would like to see how much the observed state of the atmosphere is deviated from the barotropic atmosphere, barotropic condition. That measure of deviation has an impact. More the deviation, more will be different types of implication will be there. So that's why actually what happened, adiabatic process. Why? Because when convection, generally in case of thunderstorm, when convection takes place now, it is a very fast process. It's a very, very fast process. And any fast, the processes are so fast that within so small time, hardly there is any time for exchange of heat between the inside and outside. Practically, it is not there. Even if it is there, it is very, very negligible. So that's why any fast process, actually these processes are known as thermodynamic process. Any fast processes in thermodynamics is approximated or modeled by a what is called by a model called a adiabatic process. So that's why adiabatic process. But it is very right, because it is not an materially separated. No, wall of the air sample is also made up by air. So definitely there is some exchange is there. But in the first process, during that process, the process is so fast, so that there is very less time for the exchange. So even if exchange is there, exchange is very, very small. So there is nothing wrong to approximate as a adiabatic process. I hope I have clarified your answer.
হ্যাঁ স্যার, থ্যাংক ইউ সো মাচ।
Any other question?
স্যার, আমাদের আইএমটি ভিজিটের কথা ছিল, সেটা কি আমরা করতে পারবো আমাদের প্রোগ্রাম শিডিউল অনুযায়ী?
So that I don't know. You have to consult with the concerned person. আমি বলতে পারবো না, বুঝলেন না? তো অলরেডি হয়তো কোনো ডিসিশন হয়ে গেছে। ইউ হ্যাভ টু কন্ট্যাক্ট উইথ দ্য কোঅর্ডিনেট উইথ দ্য কনসার্ন পারসন।
বাবু এদের সঙ্গে কথা বলবো, আমরা কোনো মেল পাইনি।
না, আপনি যাকে করেছেন আপনি, না
আপনাকে করেছি,
আপনাকে করা হয়েছে।
না, আমাকে করতে আমি তো কোনো অ্যাকশন নিই, আমি তো কনসার্ন পারসনকে ফরওয়ার্ড করে দিয়েছি। ওখানে একজন ডক্টর অন্বেষা ভট্টাচার্য আছেন, ওনার সাথে কথা বলবো।
আচ্ছা, ঠিক আছে স্যার, তাই করুন।
স্টুডেন্টদের আর কোনো কোয়েশ্চেন থাকলে একটু জিজ্ঞেস করো।
ওকে, সো
স্যার, আমাদের যে ইন্টার্নশিপ হচ্ছে, আমাদের দুটি কলেজের ব্যবস্থাপনায় হচ্ছে, একটি প্রভু জগৎবন্ধু কলেজ আন্দুল আর রামসদয় কলেজ আমতা। স্যার আপনি জানেন, তো আমি রামসদয় কলেজের পক্ষ থেকে বলছি, আমাদের এই যে লেকচার হলো, এটা স্টুডেন্টদের জন্য এবং টিচারদের জন্য কতখানি যে হেল্পফুল হলো বলার নয়। যদি শুধুমাত্র ইন্টার্নশিপের প্রসঙ্গই দেখি, আমাদের জিওগ্রাফি ডিপার্টমেন্টের সঙ্গে কমার্স ডিপার্টমেন্টের স্টুডেন্টরাও পার্টিসিপেট করেছে, যাদের এই ওয়েদার ক্লাইমেট এই সম্পর্কে একদম যে নলেজটা আর কি, পাঠ্য বইয়ের যে নলেজটা, সেটা একেবারেই স্কুল লেভেলের। তো তারা তো উপকৃত হলোই, এবং ওরা যে প্রজেক্ট ওয়ার্কটা করছে সেখানে এই ওয়েদার রিলেটেড সার্ভিস তারা লোকাল অ্যাক্টিভিটিতে কতখানি আর কি দিতে পারে। তো ওরা খুব কনফিউজড ছিল যে ওয়েদার সার্ভিস বলতে আমরা কি বুঝছি, মানে একেবারে ওয়েদার ক্লাইমেট বলতে কি বুঝছি, সেখান থেকে ওয়েদার সার্ভিস বলতে আমরা কি দিতে পারি। তো আজকের এই বক্তব্যের পরে, আপনার এই ডেলিভারেশনের পরে, ওদের আর কোনো রকম কোনো সন্দেহ আছে বলে আমার মনে হয় না। মানে আন্তরিক ধন্যবাদ এবং কৃতজ্ঞতা জানাই স্যার, এতখানি সমৃদ্ধ হয়েছি এবং স্টুডেন্টরাও হয়েছে, মানে সে কথা বলার নয়। অনেক ধন্যবাদ স্যার। স্টুডেন্টরা আর কারোর কোনো প্রশ্ন আছে, কিছু জানতে চাও? ফেসবুকে কি কোনো কমেন্ট এসছে? কেউ কি একটু বলবে ফেসবুকে কোনো স্টুডেন্টরা কিছু জানতে চেয়েছে কিনা?
জানতে চেয়েছে কিভাবে সাইক্লোন ডেভেলপমেন্ট হয়।
ওকে, আচ্ছা, ঠিক আছে, নো প্রবলেম। দেখুন আমি যখন সাইটগুলো দেখাচ্ছিলাম, সেখানে কয়েকটা জিনিস বলা ছিল যে সাইক্লোন ডেভেলপমেন্ট হওয়ার জন্য কতগুলো প্রিরিকুইজিট কন্ডিশন আছে। প্রথম কন্ডিশন হচ্ছে যে সমুদ্র জল, প্রথমত সাইক্লোন সমুদ্রতে হয়, ট্রপিক্যাল ওশানে হয়, সেই ওশান ওয়ার্ম থাকতে হবে, টেম্পারেচার 27 ডিগ্রি সেন্টিগ্রেডের ওপরে থাকতে হবে। এবং ওই যে 27 ডিগ্রি সেন্টিগ্রেডটা, ওটা সমুদ্র তল থেকে নিচেও প্রায় 50 মিটার পর্যন্ত থাকতে হবে। অ্যাকচুয়ালি এই জিনিসটাকে বলা হয় হিট কন্টেন্ট। মোদ্দা কথা হচ্ছে যে সাইক্লোন যে ফর্ম হবে, সাইক্লোন ধরুন একটা বাচ্চা যে ফর্ম হয়, বাচ্চা তো প্রথমে একটা এনার্জি চাই না, সেই এনার্জি বাচ্চাটি কোথা থেকে, তার মায়ের থেকে পায়। ধরুন একটি মা যদি প্রথম থেকেই খুব ফিমেল হয়ে যায়, তাহলে ন্যাচারালি সেই মায়ের যখন সন্তানের ডেলিভারি হয়, তা ন্যাচারালি দ্যাট ডেলিভারি বিকাম ভেরি ভেরি ক্রিটিক্যাল, দ্যাট উই নো ভেরি ওয়েল, ঠিক আছে না? তো এখানেও ঠিক একই ব্যাপার, যে এনার্জির দরকার না। সাইক্লোন যখন একটা ফর্ম হয়, প্রথমে একটা এনার্জি দরকার। এখানে মা হচ্ছে সমুদ্র, তাহলে সমুদ্রের এনার্জিটাকে হিট কন্টেন্ট। হিট কন্টেন্ট কার উপর নির্ভর করছে? হিট কন্টেন্ট নির্ভর করছে টেম্পারেচারের উপর, এবং সেটা টেম্পারেচারটা কত দূর আছে। অ্যাকচুয়ালি ম্যাথামেটিক্যালি এটা হচ্ছে একটা ইন্টিগ্রেশন, ইন্টিগ্রেশন সিপিটি। তো একটা সার্টেন ওই পরিমাণ একটা ওই এনার্জি থাকতে হবে। আচ্ছা, এনার্জি থাকতে হবে, এবং তারপরে কি হচ্ছে যে ওটা থাকতে হবে। দ্বিতীয় কথা হচ্ছে কি, ওটা আপনার ইকুয়েটার, একদম ইকুয়েটারের উপর হলে চলবে না। ইকুয়েটার থেকে 5 ডিগ্রি নর্থে অথবা 5 ডিগ্রি সাউথে হতে হবে আর কি। এটার কারণটা কি, তার জন্য আমি আপনাদের আর একটা মজার গল্প শোনাই। আমি যখন ছোট ছিলাম, ধরুন এই 7-8-এ পড়ি, তখন আমাদের পশ্চিমবঙ্গে খুব লোডশেডিং হতো, বুঝতে পেরেছেন? আর আমার মা প্রতিদিন হ্যারিকেন ল্যাম্পগুলি নিয়ম করে ঠিক বেলা 3টে নাগাদ খাওয়া দাওয়ার করে কাঁচ ফাঁচগুলো সুন্দর করে মুছে, তারপরে লম্ফ, ল্যাম্প, তারপরে আপনার কি বলে হ্যারিকেন ইত্যাদি, এগুলোকে মানে তেল ফেল ভরে রেখে দিত, এবং দেশলাইটাও ওখানে রেখে দিত। আর আমাদের বাড়িতে আমার বাবাও ছিলেন, কাকাও ছিলেন। কাকা ছিল সেকেন্ড ক্লাস স্মোকার, মাইনেপত্র বেশি ছিল না। তো কাকা কি করতো, কোনো রকমে ধরুন বাবার কাছ থেকে এর কাছ থেকে সিগারেট টিকেট ম্যানেজ করে নিয়ে ওখান থেকে দেশলাই সিগারেট টিকেট খেয়ে ইয়ে করতো। বাবা ছিল ফার্স্ট ক্লাস স্মোকার, নিজের সিগারেট নিজের দিয়ে কাছে রাখতো। এবার কাকা কি করতো, কাকা একটু দেরি করে আসতো, আড্ডা ফাড্ডা মেরে খাওয়া দাওয়া করে, বাড়িতে তো সিগারেট খেতে পারবে না, বাবা আছেন, তো বাইরে সিগারেটটা খেতে চলে যেত। সিগারেটটাও ধরুন হয়তো মাই ম্যানেজ করে দিত বাবার কাছ থেকে। এবার ওই দেশলাইটা নিয়ে চলে গেল, এবং কাকা হ্যাবিচুয়ালি সিগারেটটি খেয়ে দেশলাইটা যে কোথায় রেখেছে ওই জায়গাতে একদম ইনভেরিয়েবলি রাখবে না, কোথাও রাখবে কিন্তু ওই জায়গাতে রাখবে না। এবারে ধরুন সন্ধ্যাবেলায় লোডশেডিং হয়ে গেল, সন্ধ্যাবেলায় লোডশেডিং করলে আপনাকে ল্যাম্প জ্বালাতে গেলে তো আপনার দেশলাই চাই, তো দেশলাই পাওয়া যাবে না। কিন্তু আপনাদের নিশ্চয়ই মনে আছে ওই সময়, এখন তো ধরুন আমাদের সকলের একটু আধটু পয়সা হয়ে গেছে, বাড়িতে 4-5টা টর্চ, তখন কিন্তু বাড়িতে একটাই টর্চ, মানে ওই টর্চের হাত দেওয়ার ক্ষমতা কাউর না, ও এক জায়গাতে থাকবে ফিক্স। তখন মা কি করতে বলুন তো, টর্চ কোথায় আছে মা নিশ্চিত, টর্চটা নিল, আমাকে টর্চটা জ্বালালো, তারপর আমাকে বলে এই টর্চটা ধর, বলে আমি করে ধরলাম। এবার মা ধরুন ওই হ্যারিকেনের যে একটা ইয়ে আছে ওটা নিচে করে, এবার টর্চ দিয়ে প্রথমে দেশলাইটা খুঁজলো, দেশলাইটা খোঁজার পরে দেশলাইটা জ্বালালো। যেই জ্বালানোর সময় টর্চ বন্ধ কর, ব্যাটারি কমেছে। তখন তো মানুষজনের মাইনে করি কম, বাবা টাবার ছিল, ব্যাটারি অত কিনবে কোথা থেকে, টর্চ নিভিয়ে দেওয়া হলো। এবারে যখন সাইক্লোন হয় তখন দুটো ফোর্সের দরকার লাগে। একটাকে বলে প্রেসার গ্রেডিয়েন্ট ফোর্স, মানে ডিফারেন্স বিটুইন ইনার সেন্ট্রাল প্রেসার আর আউটার প্রেসার। আর একটা হচ্ছে আপনার কি বলে সেন্ট্রিফিউগাল ফোর্স। এবারে আমরা এটাও জানি প্রেসার গ্রেডিয়েন্ট ফোর্স তো সবসময় রেডি, কোনো ব্যাপার না, কিন্তু সেন্ট্রিফিউগাল ফোর্স পেতে গেলে আমার হাওয়াকে কিন্তু ঘুরতে হবে। আর হাওয়া কিন্তু প্রথমে কোনোদিনই ঘোরে না, হাওয়া কিন্তু প্রথমে সরল রেখাতেই গমন করে। এবারে সরল রেখাতে গমনরত একটি হাওয়াকে যদি আপনি বেঁকিয়ে ঘোরাতে চান, তাহলে হাওয়াকে বেঁকাতে পারে এমন কাউকে দরকার। হাওয়াকে বেঁকাতে পারে একটি ফোর্স, যার নাম হচ্ছে কোরিওলিস ফোর্স। এবং এই কোরিওলিস ফোর্স ইকুয়েটারে 0 অ্যান্ড ভেরি নিয়ার ইকুয়েটারও এটা হচ্ছে খুব কম। এই জন্যে একটা মিনিমাম অ্যামাউন্ট অফ কোরিওলিস ফোর্সের আমাদের দরকার, এবং এটা দেখা গেছে দ্যাট ইজ অ্যাভেলেবেল। হ্যাঁ মা, পরে করছি, পরে করছি, ঠিক আছে, পরে করছি মা। হ্যাঁ, সেটা দেখা গেছে যে 5 ডিগ্রি যদি ক্রস করে যায় তাহলে দ্যাট মাচ মিনিমাম অ্যামাউন্ট অফ কোরিওলিস ফোর্স ইজ রিকোয়ার্ড। তাহলে ওই মিনিমাম অ্যামাউন্ট অফ কোরিওলিস ফোর্সের দরকার, ইকুয়েটরের থেকে থাকতে হবে। আর একটা যেটা দরকার, প্রথমে একটা ছোট ডিস্টারবেন্স থাকার দরকার, যেটা আমাদের টার্মিনোলজিতে বলি ওটা একটা ইনিশিয়াল ইনস্টেবিলিটি। তো ইনিশিয়াল ইনস্টেবিলিটি নানান রকম ভাবে প্রোভাইডেড হয়। হ্যাঁ, ধরুন কোনো ওয়েভ ইস্ট থেকে ওয়েস্টের দিকে যাচ্ছে, সেই ওয়েভটাও প্রোভাইড করতে পারে নানান রকম, তার জন্য অনেক রকম মেকানিজম আছে। তবে এই জিনিসগুলো থাকার দরকার। আই হোপ I have clarified your answer. Am I clear? Have I clarified your answer?
হ্যাঁ স্যার, অ্যাকচুয়ালি স্টুডেন্ট তো ফেসবুকে আছে, ও কমেন্ট করতে পারবে না, অ্যাকোমোডেশন তো সবার নেই এই কনফারেন্স রুমে।
আচ্ছা। So any other questions?
আর মনে হয় সেরকম কোনো প্রশ্ন নেই সারদা দি, মেসেজে তো দেখছি না।
স্যারকে একটা রিকোয়েস্ট করব, যদি পারেন ক্লোজিং সেশনে, যদি আমাদের কলেজে কি পারবেন আসতে?
অ্যাকচুয়ালি এখন তো মনসুন পড়ে যাচ্ছে ম্যাডাম, এখন মনে হয় যাওয়াটা কারণ কথা হচ্ছে ওইখানে ব্যাপারটা যেতে কোনো অসুবিধে নেই। প্রবলেমটা হচ্ছে আমি যদি কোনোদিনও ওখানে যাই, ওখানে যাওয়া, ওখান থেকে ফিরে আসা, এবং ওখানে আপনাদের কোনো ফাংশন শর্ট হোক যাই হোক অ্যাটেন্ড করা, ইট মে টেক টোটাল প্রায় 4 hours, কনসিডারিং দ্য ডিস্টেন্স অ্যান্ড দ্য রোড কন্ডিশন, ট্রাফিক কন্ডিশন। তো বুঝতেই পারছেন এতক্ষণ ধরে আপনার এই মনসুন সিজন, এখন তো ধরুন সাইক্লোন সিজন, যদিও কোনো সাইক্লোন এখনো হয়নি, ঠিক আছে, কিন্তু মনসুন আসছে, তো আমাদের পক্ষে না একটু অসুবিধা আছে, বুঝলেন। তো ইট ইজ বেটার উই ক্যান হ্যাভ ইট থ্রু ভার্চুয়াল মোড তো আজকাল খুব ভালো মোড না, খুব ভালো। ইট ইজ ইকোনমিক অলসো, আপনার পয়সা খরচাও কম, সমস্ত এটাও দেখতে হবে না।
আসলে ক্লোজিংটা আমাদের মানে অফলাইনে হবার কথা আমাদের কলেজে, প্রভু জগৎবন্ধু কলেজে, ভার্চুয়াল করার কথা নেই।
ঠিক আছে, আপনার না করতে পারলে কোনো ব্যাপার না, মানে আমার বেস্ট উইশেস উইল বি অলওয়েজ দেয়ার আপনাদের প্রোগ্রামে।
থ্যাংক ইউ সো মাচ।
Okay, so if there is no question, then with your permission, can I leave the meeting?
Of course, sir. I think
হ্যাঁ ঠিক আছে স্যার, আসলে আপনি এত সুন্দর গল্প বলে বোঝাচ্ছেন, আপনাকে ছাড়তে ইচ্ছা করছেন। ঠিক আছে।